Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Cairo. I am pleased to introduce the chemistry course for the General Secondary Language School. We will start the explanation of this course by first chapter of transition elements. And in this chapter, we will start with the explanation of the first transition series. Look at the first slide. We will see the first transition series, which will start with Scandium element, which has atomic number 21, then titanium 22, then vanadium, and move from left to right till we reach zinc element. Zinc element which has atomic number 30 atomic number. Scandium element is belong to the group 3b, titanium is belong to 4b, vanadium 5b, chromium 6b, manganese 7b, cobalt, iron, cobalt, nickel are belong to the 8th group. Copper and zinc start again copper from 1b, zinc and 2b. Now we will discuss the economic importance of these elements of the first transition series. Firstly, we look to the scandium, which has 21 electrons, or its atomic number 21. It's not abundant in the Earth's crust, and it has limited uses. So the scandium has limited uses. Number 2, titanium, with atomic number 22. It's silver gray metal and more abundant in the Earth's crust. Its second element, titanium, is the second element in the first transition elements after iron. Titanium is characterized by it's very hard. Titanium resists corrosion. Titanium has low density but more than aluminum, 1.5 times. Titanium keeps its strength at high temperature. Now question, give reason. Titanium is better used than aluminum in manufacture of rocket and supersonic planes. Give reason why titanium is better used than aluminum in manufacture of rocket and supersonic planes. That's because it keeps its strength at high temperature. So we use titanium more than aluminum because it keeps its strength at high temperature. When we transfer to vanadium, vanadium has atomic number 23. It's silver gray metal, and its compound have several beautiful colors, and it's characterized by its hardness and corrosion resistance. So its alloy with iron, ferro-vanadium alloy, is used in the manufacture of car springs. The compounds of vanadium pentoxide, V2O5, which is used as catalyst in sulfuric acid industry. So vanadium pentoxide used as a catalyst in the manufacture of sulfuric industry. That method called contact method, and manufacture of benzoic acid. We can look at the equation. 2SO2 gas plus O2 give 2SO3 gas. SO3 gas plus H2O give sulfuric acid H2SO4. Now we'll study chromium with atomic number 24. It's silver gray. Its name is derived from the Greek word chromos, and characterized by A, very active, B, its ion is colored, its ions are colored. C. Resists the oxidation by oxygen at room temperature. Now, there is a question. Give reason. Chromium metal resists the action of atmospheric effects, although it's chemically active. The answer. Due to the formation of an oxide layer on the surface, where the oxide molecules are larger than the atoms on the element and forms non-porous layer, which prevents further reaction with atmospheric oxygen. This phenomenon called passivity. In B, iron compounds are covered with chromium and not the chromium compound are covered with iron. Chromium is used in electroplating metals because it resists corrosion and make them more attractive. So we use chromium in electroplating metals to resist corrosion and make them more attractive. When we look to the use of chromium, A, in stainless steel and surgical tools, iron, chrome, nickel, which contain 12% of chrome. B, in nickel alloys, example, nichrome, which contains 15% chrome, which is used in heating coils and electric irons and electric furnaces. Now we study the features or the properties of manganese. Manganese has atomic number 25. Manganese is the third most abundant transition element. It resembles iron in presence and it's used in steel production. Question. Give reason. Manganese is used in the manufacture of steel. Answer. Because it reacts with oxygen. Question again. Manganese is used in the manufacture of steel because it reacts with oxygen during the production and prevents the formation of bubbles in steel during cooling. So, manganese is used in manufacture of steel during production to prevent the formation of bubbles in steel during cooling. Now we study the compounds of manganese. 1. Manganese dioxide, MnO2, is used as catalyst and as an oxidizing agent in drying cells. 2. Potassium permanganate, KMnO4, is used as antiseptic and as oxidizing agent. Now transfer to iron. Iron has atomic number 26. It's the most abundant transition element metal in the Earth's crust and used in the manufacture of cars, ships, and tools. And it will be discussed later. Element number 7, cobalt, which has atomic number 27. Cobalt compounds have been used in coloring glasses. It occurs in vitamin B12. Cobalt has a biological importance. Number 3, it's used in formation of several alloys. So cobalt is used in formation of several alloys. Note that cobalt has 12 isotopes. Now, study cobalt compounds. Cobalt compounds. Number 1. Hydrated cobalt chloride, which is used in the manufacture of secret ink. Number 2. Anhydrous cobalt chloride, which is used in weather prediction. As you see in this slide, there is a question, give reason. Hydrated cobalt 2 chloride, COCl2, is used in the manufacture of secret ink. Because the hydrated cobalt 2 chloride has a pale pink color in diluted solution, and it changed to the dark blue color on dehydration. When we look to the equation, hydrated cobalt chloride, pale pink solution. On dehydration, we obtain cobalt chloride 2, which is anhydrous cobalt chloride, it's dark blue, plus 6H2O. Second question, anhydrous cobalt 2 chloride is used in atmospheric predictions. Because anhydrous cobalt 2 chloride has dark blue color and change to pale pink on hydration. That is seen in the equation cobalt 2 chloride, anhydrous cobalt chloride has blue color, plus 6H2O change to hydrated cobalt chloride, COCl2, 6H2O. The hydrated cobalt chloride has pale pink color. Now we transfer to the element number 8, nickel. Nickel has atomic number 28. It's used in manufacture of about 3,000 alloys, such as nichrome alloy. Number 2, it's used as catalyst in hydrogenation of oils. Number 3, it's used in plating metals to protect them from corrosion. Number 4, nickel, it's used in the manufacture of vessels which are used to store liquids like hydrogen fluoride or hydrofluoric acid, which is corrosive acid, and caustic soda, NaOH, because nickel can resist their attack. Number 5, it's ductile. Nickel is ductile. Now give reason. Caustic soda, NaOH, acids as liquid hydrogen fluoride, hydrofluoric acid are kept in nickel vessels because nickel resists corrosion and resists their attack. Nickel resists corrosion and resists the attack of caustic soda or liquid hydrofluoric acid. Number 2, nickel is used to plate other metals. Give reason. Nickel is used to plate other metals to protect them from oxidation and corrosion. Now the element number 9, copper. Copper has 29 atomic number. Copper is a soft reddish metal of high thermal and electrical conductivity. Copper has high thermal and electrical conductivities. The free element is used in electric equipment and wires. Number 3, copper is used in alloy as brass. Brass is copper plus zinc. Bronze and coins. So copper is used in alloys as brass, bronze, and coins. Give reason. Copper is used in electric wires. Answer: because copper is because copper is a good conductor to electricity. Now in this slide, we will study the electronic configuration and oxidation state of the first transition series. This table is divided to first column elements: scandium, titanium, vanadium, chromium, till zinc. Its electronic configuration, like in the table, start with argon 18, 3D subshell is divided to 5 orbitals. Then the subshell 4s. When we look to scandium, we will find the electronic configuration is argon 18 atomic number, and 3D subshell contain 1 electron, and 4s contains 2 electrons. So the oxidation number of scandium is 3. The oxidation number of scandium is 3 when we lose 2 electrons from 4s and 1 electron from 3D. We transfer to titanium. Electronic configuration of titanium: argon 18, and a 3D subshell contain in the first orbital 1 electron, second orbital 1 electron. They are unpaired electrons. And 4s contain paired 2 electrons. The oxidation number of titanium: 2, 3, 4. First oxidation number of titanium: 2 when we lose 2 electrons from 4s. Second oxidation number: 3 when we lose 2 electrons from 4s and 1 electron from orbital 3, 1 orbital of 3D subshell. When we have the oxidation, when we have the oxidation number of titanium 4 equal 4, we lose the 2 electrons from 4s sublevel and 2 electrons from 2 orbitals 3D sublevel. Vanadium, when we transfer to vanadium, the electronic configuration starts with argon 18, and sublevel 3D contain 3 electrons unpaired, 3 unpaired electrons in 3 orbitals, and in 4s there is 2 electrons paired in 4s. And we obtain oxidation number for vanadium 2, 3, 4, 5. The first oxidation number 2, we obtain it from losing 2 electrons from 4s sublevel. Then the oxidation number increase by losing electron from each orbital from the 3D sublevel. When we transfer to chromium has atomic number 24, and we will find that electronic configuration of chromium start with argon 18 and unpaired electrons in the 3D sublevel, and we will find that unpaired electron in 4s. But it should be that 4s contain two paired electrons. But actually, chromium need to reach to the stable state. The stable state for chromium that it has the sublevel 3D have 5 unpaired electrons and 5 orbitals. The 5th electron is transferred from 4s sublevel to the 5th orbital in the subshell 3D. So the electronic configuration of chromium, argon 18, and 5 orbitals, each one contains 1 unpaired electron, and 4s has unpaired electron too. Manganese has atomic number 25, and the electronic configuration of manganese, argon 18, and unpaired electron in each orbital of 3d sublevel, and paired electron in 4s. And this element has the maximum oxidation numbers 2, 3, 4, 5, 6, 7. It has the maximum oxidation numbers. When transfer to iron, which has 26 atomic number, let's start by argon 18, and the first 2 orbitals of 3d sublevel has 2 paired electrons. Then the other orbitals has 3 unpaired electrons, but the 4s has 2 paired electrons. When we look to nickel, which has atomic number 28, its electronic configuration argon 18, then the first and second, third orbitals of 3d sublevel have paired electrons, and the last 2 orbitals has 2 unpaired electrons, and the 4s of nickel has 2 paired electrons. The copper, which has atomic number 29, has the same phenomenon as chromium, and its electronic configuration is argon 18, and 5 orbitals of 3d sublevel has 5 paired electrons, and 4s has 1 electron. But it should be has 4 orbitals which have paired electrons, and the 5th orbital of 3d sublevel has 1 electron. But to reach to the stable state, it takes the second electron from 4s to complete the 5 orbitals with 10 electrons, to be filled with 10 electrons to be stable. Last element, zinc, has atomic number 30. Its electronic configuration argon 18, and the 5 orbitals of 3d sublevel are filled with 10 electrons, and 4s has 2 paired electrons. Note, elements of the first transition series lies in the fourth periodic after, in the fourth period after calcium, which has 20 atomic number. The 5 orbitals of the sublevel 3d are successively filled with unpaired electrons till manganese. Then pairing takes place. Pairing with electrons takes place after manganese. From the table, the first oxidation number increases. The first oxidation number increase in the first transition series from scandium to maximum in manganese, then decrease again to zinc, with exception of the elements of group 1b, because from scandium to manganese the number of unpaired electrons increases, and manganese to zinc pairing of electrons takes place. Note that it's clear that maximum oxidation number of any element cannot exceed its group number. The only deviation is noticed for group 1b elements: copper, silver, gold. Number 2, on oxidation. On oxidation, that means when the atom loses electrons, the atom loses first electrons from 4s. On the oxidation, the atom loses electrons from 4s. Firstly, have high quantum number. 4s have high quantum number, followed by the electron loses from the 3d lower quantum number to give the different oxidation states. So when the element on the oxidation of the element, the electrons are lost from 4s firstly, then from 3d sublevel. Number 3, transition elements are characterized by having many oxidation states. Transition elements are characterized by having more oxidation states due to the sublevel 3d is not completely filled, and the sublevel 3d and 4s are nearly equal in energy. So when the atom gains a gradually amount of energy, the 2 electrons of the sublevel 4s lose firstly. Then the electrons of sublevel 3d and sequence. As the difference in ionization energy is small, the difference in the ionization energy between 4s and 3d is small. Number 4, the atom or the ion becomes stable when the sublevel D is empty. D has no electrons, as in case of scandium 3 and titanium 4. Number B, half-filled D contains 5 electrons, as in case of manganese 2 and iron 3. Number C, completely filled with electrons. D has 10 electrons, as in case of zinc 2. So the atom or the ion becomes stable energetically when the sublevel D is empty or half filled or completely filled. Question: why iron 2 is easily oxidized to iron 3, while manganese 2 is not easily oxidized to manganese 3? Give reasons. Or why iron 2 is easily oxidized to iron 3, while manganese 2 is not easily oxidized to manganese 3. Because in case of iron, we look at the electronic configuration of iron, which has 226 atomic number. Its electronic configuration argon 18, 4s has 2 electrons, 3d has 6 electrons. So iron 2 has electronic configuration argon 18, 4s 0 electrons, it loses 2 electrons, 3d has 6 electrons. This case is less stable. Iron 3, the electronic configuration of iron 3, argon 18, 4s 0 electrons, 3d 5 electrons. That's more stable because in this case the 3d sublevel is half filled. When we look to the orbitals of 3d in the first case, we will see that the 6 electrons, first orbital has 2 paired electrons, then the other orbitals has unpaired electrons. This case is less stable because it's not half filled. On oxidation from iron 2 to iron 3, this electron is loosed. Then we obtain the 5 orbitals has unpaired electrons. And this case is half filled. This case is stable for iron 3. But in manganese, we find that manganese 2, which has the electronic configuration manganese 2, argon 18, 4s0, 3d 5 electrons in case of iron manganese 2. When we look to the orbital 3d sublevel, we will find that this 3d sublevel contain 5 unpaired electrons, and this case is stable. But on oxidation, we need high energy to lose the electron, the 5th electron, to obtain 4 electrons and empty orbital. This will be less stable state for manganese 3. The electronic configuration of chromium and copper is differ from other electronic configuration of other elements. And as we see that chromium has atomic number 24 and copper has atomic number 25, have abnormal electronic configuration because chromium 24, one electron will transfer from 4s to 3d to be half filled. So the sublevel become half filled, and this makes the atom more stable. And in case of copper, which has atomic number 29, one electron will transfer from 4s to 3d to be completely filled. And 3d sublevel becomes filled and makes the atom more stable. So when the electron transfer from 4s to 3d, 4s becomes half filled, and 3d sublevel becomes filled with 10 electrons and makes the atom more stable. You can see that in the table. We find that excited electronic configuration of chrom 24 atomic number, argon 18, 4s has 2 electrons, and 3d has 4 electrons. Okay, that's wrong electronic configuration. But the correct electronic configuration is that one electron from 4s, one electron from 4s transferred to 3d. To be 3d has 5 electrons. In case of copper 29, its electronic configuration 18, 4s has 2 electrons, 3d has 9 electrons. It's wrong electronic configuration. But actually, copper electronic configuration is argon 18, 4s has 1 electron, half filled, and 3d has 10 electrons. This case is stable for chromium and copper. Number 6, scandium gives +3 oxidation state, not 2. Give reason why scandium gives oxidation state 3, not 2. Because difference between second and third ionization potential is small. So scandium loses the 2 electrons from 4s sublevel, then 1 electron from 3d sublevel to be more stable. That means the stability of argon. Give reason. The ionization potential increases with the increasing of oxidation number. Why the ionization potential increases with the increasing of oxidation number? When we look at this equation, we find that scandium with 0 oxidation number take some energy, quantity of energy to be scandium 1. then to transfer to scandium 2 take another amount of energy. This amount of energy called ionization energy. This ionization energy is increases from 0 to 1 oxidation state to second oxidation state to third oxidation state. But to reach with scandium to fourth oxidation state, scandium 4 take higher oxidation energy. And in case of titanium has 0 oxidation state, take amount of energy to be titanium 1. This energy increases to be titanium 2. Then to be titanium 3, take another higher energy, and take very huge energy, very big energy to be titanium 4. Give reason. It's difficult to obtain scandium 4. It's difficult to obtain scandium 4. Scandium 4 ion by normal chemical methods, because the difference between the third ionization potential and the fourth ionization potential is very large during breaking of complete energy level, because difference between the third ionization potential and fourth ionization potential is very large due to breaking of the complete energy level. Other question, why potassium has only one oxidation state while vanadium has more than one oxidation state? Because in potassium the increasing in the ionization potential is very large, breaking a complete energy level, but vanadium has more than one oxidation state, because the two sublevels 4s and 3d have nearly equal energies, so they lost their electrons in sequence when the atom is oxidized. When we look to the potassium electronic configuration, argon 18 4s has one electron. It can lose this electron and has one oxidation state. But in case of vanadium, its electronic configuration argon 18 has 2 electrons in 4s sublevel and 3 electrons in 3d sublevel. So it has more than one oxidation state. The transition elements very important. They are elements in which sublevels D or F are occupied by electrons, but not completely filled either in the atomic state or in any of its oxidation state. According to this statement, we can consider that transition elements are 27 elements, not 30 elements. So we have a question, can the coinage metal, which are copper 29 with electronic configuration or the outer shell 4s has 1 electron, 3d 10 electrons, silver Ag 5s has 1 electron, 4d has 10 electrons, and gold Au with atomic number 79, the subshell 6d has electron, 5d 10 electrons, be considered as transition elements. So the question, why, or give reason, the coinage metal copper, silver, gold be considered as transition elements. Number 2, can the metals zinc, cadmium, mercury be considered as transition elements? We will see. Elements of group 1b, copper, silver, gold, they are transition elements because the sublevel D is filled in the free state, but in the oxidation state have +2, +3 oxidation states. Sublevel D is not completed. Copper has 3D, contain 10 electrons. Copper 2 has 3D, contain 9 electrons. In this case, free stable oxidation state of copper 2 3D has 9 electrons. In group 2b, zinc, cadmium, mercury, these elements non-transition elements because sublevel D is completed with electrons in the atomic state or in the oxidation state. So the elements of group 1b, copper, silver, gold, are considered transition elements because in its oxidation state has 3D sublevel not completed with electrons. But group 2b, which contains zinc, cadmium, mercury, these elements are non-transition elements. Because in the case of atomic state or oxidation state, the D sublevel is still complete with 10 electrons. So we can ask here, give reason. The main transition elements in the 3 series are 27 and not 30 elements. Write and answer these questions in the light of the last table. Now we study the general properties of the first transition elements. Question, give reason the transition elements are metals. We can answer this statement in some points. Firstly, the transition elements have the following physical properties. These physical properties point that the transition elements are metals. Number 1, they are malleable and ductile. Number 2, they have metallic luster. Number 3, they are good conductors of heat and electricity. Number 4, they have high melting point and boiling point. Number 5, they form alloys with non-transition elements. Accordingly, they are metals. Number 6, the atomic size are small. Second point, the transition elements have less than 4 electrons in their outermost shell. The force energy level contains 1 or 2 electrons. 4s has 1 electron or has 2 electrons. Accordingly, they are metals. The third point, transition elements lose their valence electrons during the chemical reaction, giving positive ions form basic oxides. So, transition elements lose their valence electrons during the chemical reactions, giving positive ions, form basic oxides. replace hydrogen in diluted acid. Accordingly they are metals. And now, after studying the properties of the transition elements, we will finish this lesson, and in the next lesson we will see some features, physical features for the transition elements gathering. Thank you and goodbye.